this eclipse has an opportunity to sort of transform us in a way, especially the younger generation who will re-experience it in America in 2024 in a very profound way. I mean, this eclipse has an opportunity to tell people that science works, the methods of science works. We can predict this event. We can predict future events. You can teach about basic geometry of what's happening during the eclipse. You can talk about our endeavor to find exoplanets, that the techniques we use in detecting exoplanets in far, far away solar system is nothing but, that particular moon in another solar system or a planet sort of casting a dip in the stellar brightness. So, if we can take people closer to that with real examples, I mean, what's better than that? I truly hope that the American students with their parents will go observe this eclipse, the total eclipse, where the spectacle is something you can't describe in words. You have to see it, and we have captured it with cameras and photographs, but nothing is like actually viewing it. I believe that I have been to 9 solar eclipses, but I have not seen all of them because eclipses can be hit or miss. And even though we have always chosen our site based on prior meteorological information, what's really fascinating about eclipse is that a totality can cause its own microclimate. Remember, it's the shadow of the moon kind of blocking sunlight for over a period of time, and that causes changes in temperature in the atmosphere, and it causes its own microclimate. So you can have snow, or you can have cloud cover just for those precious moments sometimes. So I haven't seen them all, but I have attempted 9 times, and I've seen many, I believe of the order of 6, and each one of them is glorious. Almost each and every one of them is special. For one thing, it happens during a different phase of the solar cycle. So you see each eclipse is different. During minimum, you see elongated coronal streamers, that just goes away into infinity and really looks like an eye in the sky, because you see these plumes like eyelashes in the north and south, and then you see these white streamers, pearly halo, extending into infinity. They actually do, but we can't trace them that far. During total solar eclipses, you have the entire sun surrounded by these structures, and you can actually with naked eye see activity, post-flare loops. So my first experience was the 1991 eclipse, where I was watching it like an amateur, like an astronomer with my family, lying on the beach in La Paz, and little did I realize that that was the longest eclipse I was going to watch ever in my life, because I thought it was pretty short. It was 6 minutes and 20 seconds, something like that, about longest it can get. From there I went to India in 1995. I went to Mongolia. One of the most memorable eclipse was in the Sahara Desert in 2006 in Libya, where we were invited by Gaddafi to actually participate in eclipse observation and bring some visibility of science. We went around giving talks, but that was, in the desert sky, that eclipse was pretty unbelievable. At NASA, we eclipse the sun every day, every minute, every second, right? We put occultors, these are blockers in front of our telescopes, and we are able to see the corona, the coronal mass ejections. In fact, with our mission like stereo, we are able to image this all the way past Earth. Actually, pretty incredible feat for scientists and technologies. But what we can't do is really observe the sun at its very closest, at the boundary between sort of photosphere, chromosphere, and the corona, because you put an occulter pretty close to a telescope. There is a lot of scattered light, and therefore you can't observe the environment very close to the sun. But that is the environment that is kind of critical in shaping what becomes solar wind. That is the steepest region in terms of acceleration of the solar wind, in terms of the density gradient, in terms of how the magnetic field confines the plasma around it. So we really, if you want to have better understanding, do better prediction of how the corona is escaping or how coronal mass ejections get accelerated, viewing the sun in that domain is really critical, and we haven't been able to achieve that from space in visible light. We do that in soft X-ray, and that's what you see in coronal in Solar Dynamics Observatory and many of our other missions. But in visible, we haven't been able to do it. And visible is important because that kind of gives us a clear idea of what the coronal density is. And coronal density is kind of like the building block, that shapes the structure, the corona and all of that. So scientists are still kind of trying out new technology to measure this. You can develop, better sophisticated instrument with higher spatial resolution, temperature, combining temperature and density together and velocity to extract that information. So there is a lot of new work in technology, in instrumentation also that goes on during eclipses.